In this video, we're going to look at the solution to the Corbett conundrum for the 6th of January. So the conundrum says, find the area of the circle inscribed in this isosceles trapezium. So we've got a trapezium and the length of the parallel sides are 8 centimeters for the top and 18 centimeters for the base of the trapezium. And we've been asked to find the area of the circle inscribed within that trapezium. Okay, if you haven't had a go at this puzzle now, this conundrum, pause the video, have a go at it, and if you're just waiting for the solution, just wait a moment and I'll go through the solution now. Okay, so to do that, what I'm going to do is I'm going to label some parts on the circle and on the trapezium. So first of all, I've labelled the centre of the circle. I'm going to call that O. I've labelled the midpoint of the top of the trapezium. I'm going to call that E. I've labelled the top right hand corner of the trapezium. I'll call that D. I've labelled the point C. Now the point C is where the trapezium and the circle meet. In other words, the trapezium is going to be a tangent to the circle at that particular point. I've labelled the bottom right hand corner of the trapezium. I've labelled that B. Again, A is the midpoint, and E and A are both points where the trapezium touches the circle. So they're going to be both points of where there's a tangent to the circle. And I've also labelled if the top of the circle, the top of the trapezium is 8 centimeters, that means there's going to be 4 on either side because E is the midpoint, and again 9 on either side because A is the midpoint. Okay, now what we're going to do is, to get the radius of the circle, I'm actually going to want to find out this length dB, the length of the side of the trapezium to begin with. Okay, so what I'm going to do is I'm going to connect up E to A, so the midpoint of the top and the midpoint of the bottom of the trapezium. I'm going to connect up O to B, so the center of the circle to the bottom right hand corner of the trapezium. And I'm going to join up O to C, the radius of the circle OC, and C is where the tangent or the trapezium meets the circle, so it's where there's a tangent. Okay, I'm going to mark on some angles. I know that that's going to be 90 degrees. I know where the tangent and the radius meets will be equal to 90 degrees. And likewise here, that's going to be a right angle as well. Now, we've actually got two congruent triangles here. OCB and OAB are congruent triangles. They've got the same sides and the same angles. And let's see why. So one of the conditions of congruent triangles is RHS. So right angle, hypotenuse, side. Now if you look at these two triangles, OCB and OAB, you can see they share a hypotenuse. In other words, OB is the hypotenuse for both of those, so they share that length. And also, we know that OA is the radius, and we know that OC is the radius. So we've got a right angle, a hypotenuse and side, so we know by Pythagoras' theorem that if we were to work out the length of this side, CB, and the length of this side, AB, using the two triangles, they would be the same. So that means that CB is equal to 9 centimeters also. Now, what I'm going to do is I'm going to do the same for the top of the trapezium. So up here, I'm going to connect up O to D, in other words, the center of the circle to D, which is the top right hand corner of the trapezium. And again, we've got some congruent triangles. EOD and ODC, those two triangles are congruent. Again, they've both got right angles. They both share the hypotenuse, and they both have a radius, OE and OC. So that means that the other shorter side of the right angle triangle, ED, will be the same as this one, DC. So that's going to be 4 centimeters as well. So that means that the length from D to B is equal to 13 centimeters. Now that we know the length of the side of the isosceles trapezium, now what we're going to do is we're going to focus on now finding the radius of the circle. Okay, so here we've got EOA, so again that line that joins up the midpoint of the top of the trapezium to the midpoint of the base of the trapezium, and that passes through the center of the circle. We know that because it's an isosceles trapezium. And what I've done is I've drawn a line down from the top right hand corner D straight down to the point F, which is just a point on the base of the trapezium. Now we know that the distance from A to B is going to be 9 centimeters. I know that because A is the midpoint of the base. The base was 18, so it means you've got 9 on either side. So that means that from A to B is going to be 9 centimeters. Now we know that E to D is 4 centimeters because again, E is the midpoint of the top. It's 8 centimeters long, so it means you're going to have 4 centimeters on either side. So ED is the same as AF, so that's 4 centimeters. And that means that if that's 4 centimeters, we've got 5 centimeters here from B to F. Okay, so that's how I've worked out that 5. Okay, the whole thing's 9 because this is 4, so that leaves us 5 centimeters here. Now we know the distance also from D to B is 13, so we've got a right angle triangle here. Now those of you that know your Pythagorean triplets will know that, or Pythagorean triples, you'll know that DF is going to be 12 centimeters. Just to show you, we've got a right angle triangle here. 13 is the hypotenuse, 5 is the shorter side. I want to find the length from D to F. So A squared plus B squared equals C squared. So that's 5 squared plus, let's call this Y squared, equals 13 squared. 5 squared is 25 plus Y squared is equal to 169, just squaring the 5 and the 13. And taking the 25 away will leave us Y squared equals 144, so Y equals 12. So that means from D to F is 12 centimeters. Now if D to F is 12 centimeters, that means that E to A is 12 centimeters. And most importantly, it means that from E to O will be 6 centimeters. So the radius of the circle is 6 centimeters. Now we know the radius of the circle, and that's equal to 6 centimeters. Now we can just use pi r squared to find the area of the circle. So the area of a circle is pi r squared. So that's pi times 6 squared, which would be equal to 36 pi centimeters squared, or if we want to give it as a decimal number, that would be 113.1 centimeters squared to 1 decimal place. And that's it. So that question, obviously we have looked at Pythagoras, we've looked at congruent triangles, but it's actually just quite a neat way of finding the area of that circle that's inscribed in the isosceles triangle.